Hi, in this video, I'll be solving this problem, which passes through my Facebook feed. It just showed up on my Facebook feed. I apologize if I'm going to mispronounce the person's name, Samuel Okbako. It says, consider the polynomial p of x is equal to x minus 1 times x minus 2 times x minus 3 all the way up to x minus 2026. And then if we multiply out the polynomial, then we get it in the polynomial form of starting with x to power 2026 plus, and then all the other terms have coefficients, a sub 2025 times x to the power of 2025 plus all the way down to a sub 1 times x plus a naught. And the question is to find A1 plus A3 plus A5 plus all the way up to 2025, meaning all the odd coefficients. This question is actually easier than it looks. So if you want to try it out, go ahead and press pause and try it first. But otherwise, I'll go straight into solving it. Well, first I'm going to write this polynomial in the other direction. It's just my personal preference. I'm just more comfortable with it this way. The key to solving this problem is that there are certain values of a polynomial that relate to sums and differences of the coefficients. By plugging in the right value of x, you know something about the coefficients. For example, we know that p of 0 is going to be the constant term. We also know that p of 1 is the sum of all the coefficients. So that gets us closer to the question, right? If you plug in 1, then you get a naught plus a1 times 1. That's just a1. And actually everything else too, all the other terms, when you plug in x equals 1, I'm going to add on an a2x squared here. When you plug in x equals 1, all powers of x are equal to 1. So P1 is actually just equal to the sum of all the coefficients, including the last coefficient of 1. And then we also know that P of negative 1 is equal to what? P of negative 1 is equal to, first of all, we have a naught. And then for x, it's negative 1, so it becomes minus a1. But then for x squared, negative 1 squared is a positive 1 again. So now I have plus a2. And you can see this pattern going, right? Any odd power will have a minus, and every even power will have a plus. So it's minus a3, plus, etc. And 2025 is a negative. So it's going to be minus a2025, and then plus 1. The question asks for the sum of all the odd terms. And I see here that the odd terms are different from the even terms. So I can see now that I can extract out the odd terms separately or extract out the even terms separately. If I want to extract out the even terms separately, I can just add side by side, right? If I add side by side, then all the odd terms will cancel, and I have just the even terms left. Whereas, since the question is asking for all the odd terms, if I subtract side by side, then all the even terms will cancel and all the odd terms will add up. I should do that. I should subtract side by side. So on the left, I have p of 1 minus p of negative 1. And on the right, all the even terms will cancel. The odd terms, a1 minus negative a1 equals a1 plus a1. So it's 2 times a1. The a2s are subtracted off. And the a3 here, a3 minus a negative a3 is a3 plus a3. So I have 2 times a3. That means I know I get all the way up to here. I have 2 times a sub 2025. and then the plus ones cancel. Oh, this is just 2 times that. So if I can compute P of 1 and P of negative 1, I can subtract them and divide by 2. I can do that using the given definition at the beginning. P of 1, if I plug in 1, 1, 1, 1, 1, then this is going to be 1 minus 1, which is 0. So P of 1 is 0. What happens if I plug in P of negative 1? P of negative 1, I have negative 1 here, negative 1, negative 1, negative 1. So I have negative 2 times negative 3 times negative 4 times all the way up to negative 2027. All right, so first of all, this looks like a factorial. But I have to worry about the sign of this number. Is it a positive number or is it a negative number? Well, it depends on how many factors are there. Odd factors that are negative multiply out to a negative number, whereas an even number of factors that are negative will multiply out to be a positive number. How many numbers are here? Well, let's count them. This is the first number, number 1. This is number 2. This is number 3. All the way up to this is number. I noticed that 1 is 1 less than 2. 2 is 1 less than 3. 3 is 1 less than 4. So this is going to be 1 less than 2027. So this number here is 2026. There are 2026 factors, and therefore the answer will be a positive number. So first of all, it's going to be positive. And then what's this value? The absolute value here is equal to 2 times 3 times 4 all the way up to 2027. So it looks almost like a factorial. It's just missing a factor of 1. But the factor of 1 is always there. So this is actually the same as 2027 factorial. Therefore, our sum here, the sum that we're looking for, is equal to 1/2 of P1 minus P negative 1. And P1 is 0. P negative 1 is 2027 factorial. And therefore, the whole thing is equal to negative 2027 factorial divided by 2. Box it up, and that's my final answer. Well, that was fun. Hope you had fun too. Like, share, and subscribe for more contents. Any questions or comments, put in comment section below. And thanks for watching. Bye.